Hey guys, this is 5.6 in calculus. We are doing the derivatives of inverse trig functions, okay? So a quick recap, some notation that you're going to be seeing is either arc sign or the sign with a -1 up in the exponent. Both of these notations mean inverse of the trig, okay? Now, of course, that goes with cosine, tangent, and so on and so forth. But again, you can see either of the two notations, arc or the little -1 in the exponent, okay? So what this means, arc, and if you do not remember, you can find this in the pre-cal videos. 4.7. If you need a good recap on inverse trig functions and how they work, you can find that again, pre-cal 4.7, okay? So here's my quick recap for this video. Inverse is like kind of playing Jeopardy, where if they were to tell you inverse of a value, if you look at your unit circle, you're going to be given what the sign is, and you have to find the radian or degree. So it's kind of like rewriting it and replacing. You're getting the answer here and looking for the radian or degree, okay? So if I were to ask you arc sine of -1/2, you're going to ask yourself, where on the unit circle does sine equal -1/2? Now, a quick recap from this 4.7. For sine and tangent, we look at the right side of the unit circle, and for cosine, we look at the top, okay? So if you need to pause the video and take out a unit circle, Google it really quick. That is going to make your life a lot easier. I hope if you're in my AP class, you have your unit circle so down-packed memorized, okay? So on the right side of the unit circle, sine, which are the y values, are negative on the bottom half, okay? So I know I'm going to be giving a negative radian or degree. We're going to stick to radians for today. And I know that -1/2 is found when theta equals -pi/6, okay? And that's your answer right there. Arc cosine. Cosine, I look at the top half of the unit circle, and it's asking me when is cosine, the x value, 0. Okay, and I can find that when theta is pi/2. Again, if this, you're wondering how in the world am I getting these values, 1, go over your 4.7 video, and 2, take out a unit circle. All right? Letter C, arc tangent of radical 3. Well, tangent, I'm looking at the right side, and I know tangents are positive in quadrant 1, so I can find a radical 3 for tangent. Remember, tangent is dividing the sine by the cosine, and I can find that at pi/3. For this next question, notice that there's more going on in the inside than just a number, and there's a variable, which means all I can do here is really just solve for x. Now, this comes from pre-cal 5.5. Also very important section. And that's solving trig equations, okay? So, I can't isolate the x until I've gotten rid of the trig function. So my first goal is going to be to isolate this guy. All right, and the way I can do that is by applying a tangent to both sides. Now, the reason why I do that is because, remember back in middle school when you learned to first solve for x, your teacher taught you to do inverse operations. So if you had a +3, you would do the inverse, which was a -3. Well, the inverse of an arc tangent is just a regular tangent. So if I apply a tangent, I'm going to write it down here, to both sides, okay? This one's going to cross out because, again, these are inverse operations of each other. And I'm just left with 2x minus 3 equals tangent of pi/4. Okay? Now, I know on my unit circle, again, hopefully you have this memorized, that tangent of pi/4 equals 1. So I have 2x minus 3 equals 1. And now, just like middle school, continue solving for x, add your 3. We have 2x equals 4, and then divide by 2, and we have x equals 2. All right, so there's your review. Now let's talk about the derivatives, okay? Now these are probably the trickiest to memorize, okay? But solving, once you have them memorized, are probably the easiest, okay? So for starters, let me ease your mind by letting you know that you do not have to memorize 6. You technically have to memorize 3. As if you've noticed, this derivative of arc sine is identical to the derivative of arc cosine, except cosine is the negative. Now, if you've heard me say this in the past when I first taught derivatives, that c's get negatives, right? Whenever you do derivatives. So the derivative of a cosine is a negative sign, okay? And so forth. So the same rule applies here. The arc derivatives of trig functions with c's, cosine, cotangent, and cosecant get the negative, all right? So again, cosine is identical to sine, just with a negative. Cotangent is identical to tangent, just with a negative. And cosecant's derivative is identical to secant's, just with a negative. So we just reduced this from memorizing 6 to memorizing 3, okay? So arc sine of a function, whatever that function on the inside will be represented here with you, you'll do the derivative of that in the numerator over square root of 1 minus that squared. For tangent, it's, again, notice all 3 of them have the u prime in the numerator. So that's one less thing that you hopefully have to memorize different for each. It's just memorizing the 3 different denominators. So derivative of whatever's inside of the tangent in the numerator over 1 plus that function squared. For arcsecant, again, it's that function, its derivative in the numerator, and then the denominator is absolute value of that function times square root of that function squared minus 1. Be careful, very common for these two to get mixed up, okay? Very different, but look very similar. 1 minus u squared up here, and down here is u squared minus 1. So let's see what some of these examples look like. All right, we're going to do 4 examples, and that's it. This is exactly, as I said, very easy once you have the rules memorized, okay? So arc sine, here's my u, is my 2x. So I have u prime in the numerator. So if this is my u, derivative of u would be 2 over square root of 1 minus u squared. Now, the way you're going to see this in a multiple choice is you're going to see this clean. So I'm going to put 2 over square root of 1 minus. Remember that exponent belongs to both terms. Be careful not to put 2x squared. You can bet just about anything that 2x squared is going to be an option in the multiple choice, but it will be wrong. It's how they trick students, okay? You must give that exponent to both of them. All right, let's move on to arctangent. Here's my u, it's 3x. So y prime is u prime, derivative of 3x is just 3, over 1 plus u, which is 3x, squared. And as I said before, you can imagine that 3x squared is going to be an option on the multiple choice, and it would be incorrect. That squared needs to go to both of them. So it is 3 over 1 plus 9x squared. The entire u function has to get squared. All right. Now, let's look at this one. Arc sine of square root of x. If you would like to rewrite it first, always suggest rewriting. If you could do it in your head, fantastic as well. As x raised to the 1/2. Okay. So here we have arc sine's rule is derivative u prime in the numerator. Okay, so here I have a power rule. I have half x raised to the negative 1/2. I subtract 1 from the exponent over square root of 1 minus u, which is x to the 1/2 squared. All right, so a few things are going to happen here. Because this is a 1/2, this is a fraction within a fraction, this 2 is going to come to the denominator. And because this x raised to the negative 1/2 has a negative exponent, that's also going to come to the denominator. Okay, so that's the first thing that's going to happen. So I'm going to have 1 over 2 And you can write x to the 1/2, or you can go back to saying square root of x. And now times square root of 1 minus exponent to an exponent you multiply. So 1/2 times 2 is just 1, so it's x to the first power. And now radicals can be multiplied together. So that means I am allowed to distribute this in here. Okay? So 1/2, put one big square root. X times 1 is x, minus x times x is x squared. And again, I sound like a broken record, but always take a peek at those multiple choice options. You don't want to clean extra when you don't have to, okay? You can start catching these things by looking at the multiple choice options. All right, now for our last one, arc secant, okay? My u function is an e raised to 2x. So first is same numerator as always, okay? We have derivative of this function. This is an e function, so now you have multiple rules happening at once, okay? So derivative of this is rewrite e to the 2x times derivative of the exponent, which is just 2, over absolute value of u, e to the 2x, times square root of the u function squared minus 1. All right, now we've got some cleaning up to do, and I want to give you a heads up on something that they might try and trick you on. Okay, for starters, the numerator, you're going to see that coefficient of 2 in the front. Okay. Second of all, in a multiple choice, they would drop these absolute value bars. Okay. Reason being, the graph of e to the x, let's ignore the 2 for a second, e to the x, right, it goes like this, with an asymptote right here. Okay, so that e to the x function is always positive, always above the x-axis. It's never down here in the negatives. Now the 2 in that 2x, it's just a stretch or shrink of the graph, okay? So stretching or shrinking this does not affect it going down into the negatives. Now the purpose of an absolute value bar is so that you know that whatever comes out of here, they want it to always be positive. Well, since this is already going to always be positive, you do not need the absolute value bars. So in a multiple choice, they might try and trick you by taking them away and you thinking it's not the right answer, but it is equivalent, okay? And last, we have an exponent to an exponent, so we multiply. 2x times 2, I can write e raised to 4x minus 1. And you're done.